Have you ever really thought about what's happening between your car's engine and the wheels that actually hit the road? There's this whole hidden world of mechanical magic in there. It's called the transmission. And today, we're going to pull back the curtain and see exactly how these amazing devices take the raw, chaotic power of an engine and turn it into smooth, controllable motion. So first things first, why do we even need these complicated chunks of metal? Well, it all boils down to one fundamental engineering problem that every single car with a combustion engine has to solve.
I mean, it's a fair question, right? It seems so much simpler. Just connect the engine straight to the wheels. Job done. But as it turns out, the physics of it all, they just don't play nice. There's a huge disconnect.
And this right here, this is the core of the problem. Your engine is like a world-class sprinter. It's only happy, it's only efficient when it's spinning super, super fast, but in a really narrow comfort zone of RPMs. The wheels, on the other hand, they're the decathletes. They have to do everything. They need to crawl along in traffic, they need to cruise at highway speeds, and they need to handle everything in between. You just can't hook a sprinter directly up to a decathlete and expect good results.
And that is where the transmission steps in. It's the perfect translator. It takes all that high-speed, low-force power from the engine and cleverly converts it into low-speed, high-torque power. And torque, that's just a fancy word for twisting force, which is exactly what you need to get a multi-ton vehicle moving from a dead stop. Then, as you speed up, the transmission keeps shifting to make sure the engine stays right in that happy, efficient sweet spot.
All right, so this brings us to the big debate, the two major schools of thought in the transmission universe. It's a choice that has basically defined the driving experience for decades. Do you want to shift the gears yourself, or do you want the car to do all the work for you?
On one side, you've got the classic manual. You know, the clutch pedal, the stick shift. You are in control, directly connected to the machine. Then you've got the automatic, which takes care of all that mechanical ballet for you. And what used to be a luxury item has pretty much become the default now, especially as we're seeing more and more hybrids and electric vehicles on the road. But here's where things get really interesting. We all use that word, automatic, like it means just one thing. But that's not the whole story, not even close. There's actually a whole family tree of different technologies all hiding under that one simple name. Yup, that one simple idea of an automatic transmission actually branches out into several completely different engineering paths, and each one has its own personality, its own strengths and weaknesses. So, let's meet the family. First up, you've got the OG, the classic hydraulic automatic. The secret sauce here is something called a torque converter. Okay, picture this. You have two fans facing each other. One's plugged in, the other isn't. When you turn on the first fan, the air it pushes starts to spin the second one, right? Even though they're not touching. A torque converter does the exact same thing, but with fluid instead of air, which is what gives you those buttery smooth shifts. And deep inside, it uses these incredibly clever planetary gear sets to handle the actual gear changes. Next, we have the high-performance sibling in the family, the dual-clutch transmission, or DCT. The easiest way to think about this is like having two manual gearboxes crammed into one case. Seriously, one clutch has all the odd gears ready to go, first, third, fifth, while the other clutch has the even gears, second, fourth, sixth, already lined up. This means the next gear is always pre-selected, just waiting, which lets it shift almost instantly. And when I say instantly, I mean it. How fast are we talking? Well, a really high-end Tremec DCT, like the kind you'd find in a serious performance car, can bang through a gear change in as little as 80 milliseconds. That is, quite literally, faster than you can blink. It's just pure, raw performance. And finally, we have the smoothest operator of the bunch, the continuously variable transmission, or CVT. This thing throws the whole idea of separate gears right out the window. Instead, it uses a super strong belt that runs between two cone-shaped pulleys. These pulleys can move closer together or farther apart, which changes the gear ratio. The result? A literally infinite number of ratios, which lets the engine stay at its most efficient RPM all the time. It feels like one long, seamless gear. Okay, so we've seen the big picture systems. Now let's get down to the nitty-gritty, the heart and soul of every single one of these designs, the gears themselves. These are the fundamental building blocks of motion. The simplest type are spur gears. See how their teeth are cut straight across? They're strong, they're efficient, but that straight-on contact, it can be pretty noisy, whiny even. The solution? Helical gears. Their teeth are cut at an angle, so they engage gradually and smoothly. This makes them way, way quieter, which is exactly what you want in a car. Now there's a trade-off. Those angled teeth create a constant sideways pushing force called axial thrust, and engineers have to account for that with stronger bearings. It's a classic trade-off. You get quietness, but you pay for it with a bit more complexity. Then you've got the real specialists. Worm gears are amazing. They can give you these massive gear reductions, like 100-to-1, in a really tiny package. Plus, they're often self-locking, meaning you can't drive them backward, which is perfect for something like a winch or a hoist. And then you have the Planetary gear set. By having these little planet gears orbiting a central sun gear, you can handle a ton of torque in an incredibly compact space. This is that little piece of genius that makes most traditional automatics work. So with all these different transmissions and all these different gears, how on earth do engineers pick the right one for any given job? Well, it's not just a gut feeling. It's a very calculated process of matching the right hardware to the demands of the real world. And one of the key tools they use is this thing called a service factor. The best way to think of it is as a safety multiplier, or a fudge factor. It's a number that helps account for how hard the gearbox is actually going to be working. Is it going to run 24/7? Is it going to face sudden heavy shocks or just smooth, consistent loads? The service factor makes sure that the gearbox you choose is tough enough to survive in the wild, not just on paper in a lab. And they don't just pull this number out of thin air. Engineers use standardized charts, just like this one from AGMA, the American Gear Manufacturers Association. They just look up the type of motor being used, how many hours a day it's going to run, and what the load is like. Is it uniform and smooth, or is it a heavy, jerky shock load? So, for example, let's say you're designing a big industrial conveyor belt at a rock quarry. It runs more than 10 hours a day and gets hit with heavy, sudden loads all the time. You'd look at the chart and it would tell you to use a service factor of 1.75. That means the gearbox you pick has to have a power rating that's at least 75% higher than what the motor actually puts out, just to make sure it has the guts to survive that brutal job long term. And here's the thing. We started this journey by talking about cars. But these exact same principles, these same components, they are absolutely fundamental to almost every piece of modern technology you can imagine. The world literally runs on gears. I mean, just look at this list. It's incredible. From the landing gear on a 747 to the tiny, precise robotic arms that build our electronics. From the giant conveyors in a factory to the delicate instruments in a hospital. Cranes, hoists, food mixers. It's all the same core technology, just scaled up or down and tweaked for the specific job. So at the end of the day, it all boils down to this. There's no such thing as one best gear or one best gearbox. Every single choice is a deliberate engineering trade-off. Do you need it to be quiet? Do you need it to handle massive torque in a tiny space? Is maximum efficiency the most important thing? Or do you need it to be self-locking for safety? The answers to those questions determine which design gets the job. It's pretty amazing when you stop and think about it. All these transmissions and gearboxes, they are the true unsung heroes of our modern world, just silently, tirelessly translating power into progress all around us all the time. It really makes you wonder, doesn't it? What unseen machinery, what invisible gears are making your life work right this second? Thanks for joining me for this one.